Hello, today we will learn about probability distributions. After this lesson, you will be able to distinguish between discrete and continuous random variables, find missing probability values in the probability distributions, calculate the mean, standard deviation, and variances of the probability distributions. Let's review essential vocabulary. Random variable is a value associated with each outcome of the probability experiment. Discrete random variable is a random variable that has countable numbers of possible outcomes, for example, things you can count. Continuous random variable is a random variable that has uncountable number of possible outcomes, and it's things you can measure. Discrete probability distribution is a list of all possible outcomes of a random variable and the probability of each outcome. Expected value is the mean of a random variable. Mean is the average of the numbers better known as the calculated central value of a set of numbers. Variance is the measure of how spread out numbers are. It is the average of the squared difference from the mean. Its symbol is sigma squared. Standard deviation is a measure of how spread out numbers are. Its symbol is the Greek letter sigma. The formula is easy to remember. You take the square root of the variance. Now let's decide whether the random variable x is discrete or continuous. Below you will see 4 examples. So let's start off with example number 1. The number of accidents, x, random variable, in 1 year on I-10. Since you can count the number of accidents, the random variable is discrete. Example number 2. The length of time x it takes you to get to school. Since you can measure the time it takes you to get to school, then the random variable is continuous. Example number 3. The volume x of a fish tank. Since you can measure the volume of a fish tank, the random variable is continuous. Example number 4. The number of rolls, x, that it takes to roll a 6. Since you can count the number of rolls, the outcome, then the random variable is discrete. So to summarize, if you can count the outcomes, then the random variable is discrete. And if you can measure the outcome or outcomes, then the random variable is continuous. Now you try it. I have given you 2 examples, example A and example B. I would like you to pause the video and decide whether the random variables are discrete and continuous and explain why, and resume the video when you're ready to check your answers. Let's see how you did. Example A. X represents the number of students at Crosby High School. Because you can count the number of students at Crosby High School, the outcome, then the random variable is discrete. Example B. X represents the volume of water in a pool. Because you can measure the volume of a pool, then the random variable is continuous. Now, let's find the missing probability values in the probability distribution. So example number 5. The ASPCA surveyed households in Orlando, Florida. The random variable x represents the number of pets in the households. So if we look, because we can count the number of pets, then the random variable is discrete. So x represents the number of pets in each household, and the probability of the outcome, p of x, is below. So for example, to make sure you understand the table, households in Orlando, Florida, if they don't have any pets, then the probability of them not having a pet is 0.14 or 1400ths. If we go further to the right on the table, the probability of a household having 4 pets is 1/10 or 10/100. Now to find the missing value, if you look here, the table for number of pets 2 is missing the probability. So the probability of the outcome must add up to 1. So what I did is I added the probabilities for number of pets 0, 1, 3, 4, and 5, and took that sum and subtracted it from 1. So if you look to the right, I used my TI-83 plus calculator and entered the exact values that I wrote in red, and it gave me 1800s. So the probability of a household having 2 pets in Orlando, Florida is 1800s. Okay, now let's calculate the mean. The mean is the sum of the random variable x times the probability of the outcomes. So I used the table in the previous slides, and I entered that data on my TI-83 plus calculator. So for example, if you focus on the calculator, if there is 1 pet, the probability of that household or households in Orlando, Florida having 1 pet is 2700s, so I multiplied that by 1. The probability of households in Orlando, Florida having 2 pets is 1800, so I multiplied that by 2. So I entered all the values from my table, and it gave me the mean of 2, which is the average value. Next, I calculated the variance, and the variance is how spread out the data is. Basically what I did was I took the value of x, the random variable, I subtracted that from the mean of 2, squared the difference, and then multiplied that times the probability of the outcome. So, for example, if you look at my calculator, the mean was 2. My table first had a 0 number of pets, so I found the difference, took the square of that, and multiplied it times the probability of 1400s. I went ahead and inputted all the values into my calculator, and it gave me a variance of 1 7/10 or 1 700s. Next, I calculated the standard deviation, and the standard deviation is really simple to calculate. Basically, it's the square root of the variance. So the variance was 1 7/10 or 1 700s, and when you take the square root, you see the value that it gives, and I rounded that value to the nearest thousandths, and I wrote 1 304 thousandths. Now here you see all the answers in one slide. The mean is 2, standard deviation is 1 304 thousandths. The variance is 1 7/10 or 1 700 thousandths. And to interpret the content, there are 2 pets on average in households in Orlando, Florida. This is typically off by the standard deviation of 1 304 thousandths pets from the mean number of pets, which is 2. Now it's your turn. So I want you to find the missing probability, for example 6, and calculate the mean, standard deviation, and variances of the probability distribution for problem 6, and interpret the content. Pause the video, and once you have performed the calculations, resume the video to check your answers. And here's the answer for number 6. The missing probability value was 25 over 100. And basically what you had to do was you had to sum or add up the probability of the outcomes that was given, subtract that from one whole or 1. But since they gave you the probability of the outcomes as a fraction, then you would subtract that from 1,000 over 1,000 to give you your answer and the missing probability for the random variable of 1. Now, the mean for problem number 6 was 3 and 615 thousandths. The standard deviation was 1 and 447 thousandths. The variance was 2 and 94 thousandths. And to interpret the contents, on average, there are 3 and 615 thousandths internet devices in households in Orlando. This will be typically off the standard deviation of 1 and 447 thousandths from the mean. I hope that you understand probability distributions better, and if you have any questions, feel free to replay the video, pause it, and take good notes. Thanks for watching.